So this first question is asking you to find the exact value of each expression. So remember that sine is only defined for an inverse in these two quadrants, right? So in quadrant 1 and 4. So basically for all values from negative pi over 2 to positive pi over 2. So that's where it is defined. So when the angle is negative pi over 2, the value of sine is negative 1, right? So this is the y value corresponding to that. So the sine value is negative 1, 0, 0, and then pi over 2, 1. So these are the values that it is defined for. So that means sine inverse of negative 1 is negative pi over 2. Now this is for sine. For cosine, it is defined in this from 0 to pi. So when cosine is angle is 0, cosine has a value of 1. And when this is pi, it has a value of negative 1. So this is where it is defined for, which means cosine inverse of negative 1 is pi, right? So in another word to see it is here what we are saying is that sine of negative pi over 2 is negative 1. Likewise, cosine pi is also negative 1. So the same thing we are now carrying to tan inverse. Again, tangent is also defined for an inverse in these two, except that at pi over 2 and negative pi over 2, it is undefined, right? Okay, so then this is our 0, 0. So where is tan inverse of negative 1? That is this angle. So this angle negative pi over 4, tan inverse is going to have a value of negative 1. Sine inverse of root 2 over 2. So if your sine inverse is positive, that means your angle is in the first quadrant. So in the first quadrant for pi over 4, you have root 2 over 2 as the value. So then this is going to be pi over 4. Cosine inverse of negative half. Remember, cosine is defined where? In between these two intervals, right? 0 to pi. Now here, cosine is negative, meaning it's in the second quadrant. Where is it here? So this is the angle that you're looking for. And this angle is 2 pi over 3. Okay. Tan inverse of negative root 3 over 3. Again, tangent is negative in the fourth quadrant. In order for it to be root 3 over 3, the angle that we are looking for is negative pi over 6. Okay. Then sine inverse of pi over 2. I'm sorry, 1 half. So this first quadrant, 1 half. So this angle, pi over 6, is where sine has a value of 1 half. Okay. Does this make sense? So you have to make sure that you find the angle in the first or the fourth quadrants for sine and tangent, and the first and second quadrant for cosine. And when you're writing the answer in the fourth quadrant for sine and tangent, make sure that your angle is a negative angle. Okay. So here you're looking at a composite function. Sine inverse is composed with sine, tan inverse is composed with tangent. Now, what does the rule say? The rule says that sine inverse of sine of any angle will be the angle itself, provided your angle is in the interval negative pi over 2 to positive pi over 2, as long as it is in this interval. Now you have to make sure that negative pi over 10 is in this interval It is, right, because negative 1/10 is 0.1 and negative 1/2 is 0.5. So 0.1 is within that 0.5 interval. Therefore, this value is just negative pi over 10. And that's it. Now the same thing holds good for tangent. Tan inverse of tan theta will be equal to theta provided that your angle is in the interval negative pi over 2 to positive pi over 2. Now is negative 3/8 between those two values? So this is how I want you to look at. So this is negative 1/2 of pi. This is positive 1/2 of pi. So this is negative 0.5. That is positive 0.5. What is 3/8? 3/8 is less than half, correct? So it has to fall within that. So then this is equal to negative 3 pi over 8. Because if you convert everything into over 8, this will be 4 over 8. This will also be 4 over 8, right? And so 3 over 8 is somewhere here. So it is going to fall within that interval. Okay, so now we are going to use the same property, but as you can very well see, 11 pi over 4 is not in the interval. So let's graph 11 pi over 4. Where is it? 11 pi over 4 is nothing but 8 pi over 4 plus 3 pi over 4. Now 8 pi over 4 goes away because it's one revolution. So where is 3 pi over 4? 3 pi over 4 is here. So that is definitely not in the interval that we are looking for an inverse sine function because you want it to fall in here. Now, if you look at the angle in the second quadrant, you know that it has a sine has a positive value in the second quadrant. So the corresponding angle with the same sine value should fall in the first quadrant. So what you are trying to do is you're trying to find an equivalent angle which will have the same sine value, correct? So the same sine value, if you want to look at 3 pi over 4, same sine value for pi over 4. So this answer is pi over 4. Okay, so what you are doing is you are rewriting 11 pi over 4, finding the value of that and finding an angle in the first or fourth quadrant where sine will have the same value. So now let me illustrate for cosine, okay? So cosine, remember, it's only defined for an inverse in these two quadrants, quadrant 1 and quadrant 2. So we have to fit it in that quadrant. But first, let's see where is negative 5 pi over 3. So negative 5 pi over 3 will be pi over 3, 2 pi, 4 pi, 5 pi over 3. So this is where it is. This is negative 5 pi over 3. Okay. So this is falling in the first quadrant, correct? What is an equivalent angle in the first quadrant? Because we want an angle in the first quadrant. The angle will be pi over 3, right? So that will be the answer to this question, pi over 3, because cosine negative 5 pi over 3 has the same value as cosine pi over 3, and you want to write the answer as pi over 3, not negative pi over 3. I'm sorry, not negative 5 pi over 3, because you want to write your answer between 0 to pi, because that is where cosine is defined for an inverse. So one more. So here we are going to see where this angle is, right? The same procedure. So tangent, as you recall, where is tangent defined for an inverse? Tangent is defined for an inverse in the between negative pi over 2 to positive pi over 2. So keep that in mind. Now let's see where this angle is, negative 2 pi over 3. So you're starting from here, negative pi over 3, negative 2 pi over 3 is here. So this is negative 2 pi over 3. It clearly falls outside the interval where tangent was defined for an inverse. Now it's falling in quadrant 3, correct? In quadrant 3, tangent is positive. So if you're trying to find an equivalent angle within that black semicircle where we have highlighted, then that corresponding angle should be here, right? Because tangent is positive in the first quadrant, and this angle will be pi over 3. So in this next one, again, cosine is defined for an inverse in these two quadrants, 1 and 2. Now where is 4 pi over 3? 4 pi over 3 is here. This is 4 pi over 3. Obviously, that is outside the interval where we are looking at. Okay. Now, in the third quadrant, cosine is negative. So, a corresponding angle, if I'm finding for cosine, has to either come from 1 or 2, correct? But in quadrant 1, cosine is positive. So, that's not what I'm looking at. So, therefore, I go to quadrant 2. In quadrant 2, what is the angle? The angle is 2 pi over 3. So that is what I am looking at. So now if you see, your inner function is the inverse function. So the rule is that cosine of cosine inverse of any number is the number itself, provided the number is between -1 and 1. That's a simple rule. So when your inner function is the inverse function, you don't have to worry too much, except just looking whether it satisfies the domain requirement. That's all. Is negative 2/3 between -1 and 1? The answer is yes, right? So this answer is -2/3, and you are done. No more work necessary. Likewise here, tan of tan inverse of x is x, provided you have, so for tangent, it's pretty awesome because tangent inverse, it can take in any real number as its input. Therefore, you don't have to worry too much about fitting it into -1 and 1 or something like that. So it's going to be anything that you have is going to be the answer. Okay, so now look at this. Remember, sine of sine inverse will be x only if x falls between -1 and 1. Obviously, -2 is not between -1 and 1. So that means there is no solution for this. You cannot fit this to work for you. No solution, because there is no angle for which sine of that angle is going to have a value of -2, right? So there is no solution. As far as tan inverse is concerned, I told you it's very forgiving. Anything you have as the input is the answer. No worries. Again, -1.5 is outside -1 and 1. Therefore, there is no solution. Or as they say, you can say not defined. Okay, so now here we are solving equations. So first you have 4 sine inverse of x is pi. So as you would solve any equation, isolate your variable. In this case, it is sine inverse of x. Move the 4 to the other side. Then rewrite this as x equals sine pi over 4. This is the property of inverse. Now, what is sine pi over 4? Root 2 over 2, and that's your solution. 2 cosine inverse of x is pi. Cosine inverse of x is pi over 2. X is cosine pi over 2, which is 0. All right. Now, 3 cosine inverse of 2x is 2 pi. Divide by 3 on both sides. You have 2 pi over 3. 2x is cosine 2 pi over 3. What is cosine 2 pi over 3? Second quadrant cosine is negative, so it is negative 1/2. So if 2x is negative 1/2, x will be negative 1/4, and that is your answer. Negative 6 sine inverse of 3x is pi. That means sine inverse of 3x is negative pi over 6. That means 3x is sine negative pi over 6, which is negative 1/2, right? Because sine is an odd function. That means x will be negative 1/6. Okay? All right. Okay. 4 cosine inverse of x minus 2 pi is 2 cosine inverse of x. Now bring all the cosine inverse of x to one side. So this will become like so. Move the negative 2 pi to the other side. Now combine the like terms. So 4 minus 2 is 2. Divide by 2 on both sides. And then rewrite it like so, which means x has a value of negative 1. 5 sine inverse of x minus 2 pi is 2 sine inverse of x minus 3 pi. Again, you're collecting all the like terms together and then divide it. Set it like so. And that's your answer. Okay. So when you are isolating the variables, collect all the inverse function together on the left and the angles on the right, and then find the value. Okay, find the exact value. Secant inverse of negative 2. Now let's make that into some angle x. Even if you want, if it needs to be obvious to you, make it into some angle theta, right? Then what this says is secant theta is negative 2, correct? Now what is secant after all? Secant is nothing but 1 over cosine, which means cosine theta is negative 1/2. Now where is cosine theta negative 1/2 in this interval? We know that. That is 2 pi over 3. Okay. Cosecant inverse of negative root 3 over 2 root 3 over 3. Let that be equal to some angle theta, which means cosecant theta is negative 2 root 3 over 3, which means sine theta will be the reciprocal of that, which is negative root 3 over 2, because negative 1 over negative 2 root 3 over 3 will be negative 3 over 2 root 3, which is negative root 3 over 2. Okay, so that's how I got that. Now, where is sine theta negative root 3 over 2 in the interval negative pi over 2 to positive pi over 2? The answer will be negative pi over 3. All right. Last one. Cotangent inverse of negative root 3 over 3, let it be some angle theta, which means cotangent theta is negative root 3 over 3, which means tan theta is negative root 3, and tan theta is negative root 3, meaning it is going to be, the angle is going to be negative pi over 3. Okay. Okay, so now I'm supposed to find cosine of sine inverse of root 2 over 2. I'll show you two methods, all right? Method 1. In method 1, this is a unit circle value, correct? It's a unit circle value. If it is a unit circle value, you know that sine inverse of root 2 over 2, if it is some angle theta, then theta has to be pi over 4. You know that, okay? So if you know that, you can automatically make this pi over 4 and write your answer. That's method 1, okay? In method 2, what you will do is, you will set the inner function to be some angle theta, okay? So the inner function is some angle theta. That means sine theta is root 2 over 2. Okay. Now, what is sine theta? Sine theta is y over r, correct? So you have y over r. Y is root 2. R is 2. Then what is x? If you solve it using the Pythagorean theorem or the fact that x squared plus y squared is r squared, you will solve for x to be also root 2. That means cosine theta is root 2 over 2. So this is an elaborate way of solving, and we will adapt this method where it is needed. I'll show you where it will be applicable. Whereas when you have a unit circle value, feel free to just use that value. I'll demonstrate again with the next example. So where is cosine 1/2 in the interval 0 to pi? It's going to be for pi over 3. So then this whole inner function becomes this, right? Cosine inverse of 1/2 has a value of pi over 3. So just replace it. And then what is sine pi over 3? Root 3 over 2. So that's your answer. Okay. Okay. Now, here we will employ that method 2 I was talking about. So let's do this. The method is going to take a little bit of space. Okay, so we are doing tan of, okay, this is also unit circle. So yeah, okay, so that means I'll just stick to method 1. Unit circle angle, sine inverse of -1/2, fourth quadrant, -1/2 will be -pi over 6. What is tan -pi over 6? Negative root 3 over 3. Done. Secant of cosine inverse of 1/2. Cosine inverse of 1/2 is pi over 3. Secant pi over 3 is 1 over cosine pi over 3, which is 1 over 1/2, and that is 2. Okay, secant tan inverse of root 3. Tan inverse of root 3, what is the corresponding angle? It's in quadrant 1. Quadrant 1, pi over 3. Secant pi over 3. 2. Sine of tan inverse of -1. Tan inverse of -1, quadrant 4. It's negative pi over 4. Sine negative pi over 4 is negative root 2 over 2. Sine inverse of cosine -7 pi over 6. Okay, what is cosine -7 pi over 6? Where is -7 pi over 6, first of all? That is pi plus pi over 6, right? So that is here in this quadrant, right? In that quadrant, cosine is negative, right? So that will be negative root 3 over 2. Am I right? So sine inverse of negative root 3 over 2, that puts the angle in the fourth quadrant. Fourth quadrant, root 3 over 2. That means the answer I'm looking for is negative pi over 3. Okay. Cosine inverse of tan negative pi over 4. What is my step 1? Look at this carefully. Step 1, find this value. What is tan negative pi over 4? Negative angle, right? Fourth quadrant, which is -1, is this value. Okay, so that means this becomes cosine inverse of -1. Now, where is cosine inverse -1? It's going to be for the angle pi. Okay, so now we are moving on to values which are not unit circle. Okay, so look closely. This is not a unit circle value, right? So then you have to use method 2, no choice. Okay, so let's do this step by step. Okay. In the first step, you will let some angle theta be the whole inner function, okay? Which means sine theta will be root 2 over 3. What is sine theta? Sine theta is y over r. And your original problem, if you made this whole thing to be equal to theta, you are interested in finding cosine theta. What is cosine theta? X over r. So you know y, you know r, you don't know x. But since sine inverse was positive, you know the angle is in quadrant 1. So you know x is also positive. How do you find x? X squared plus y squared is r squared. X squared plus 2 is 9. X squared is 7. X is square root of 7. I'm not considering okay, I'll put plus or minus, and then I will only use positive. Why am I only using positive? Because it's in quadrant 1. So the answer will be cosine theta is square root of 7 over 3. Okay. Now let's do the second one. So let the inner angle be this, sine inverse of negative root 2 over 3, which means sine theta is negative root 2 over 3. Sine theta is y over r, and cotangent theta is x over y. So I need to find x, okay? So again, x squared plus y squared is r squared. Now, since sine inverse has a negative value, I'm looking for an angle in quadrant 4. In quadrant 4, cotangent is negative. So keep that in mind, which means my x value is, of course, positive, but the y value is negative. So then solve it. You know that x is still positive. It's the same thing as the previous problem, so I'm not showing the steps, but the x value is still positive because it's quadrant 4. So my cotangent theta will be root 7 over negative root 2, correct? Because y value is root 2. Okay, so that is my answer. Okay. Okay, more problems of the similar kind, but these two, this can be solved, like the third one can be solved without much work because I know the value of cosine 3 pi over 4, right? It's in the second quadrant, so that will be negative root 2 over 2. And this one for sine inverse is in the fourth quadrant, so the answer is negative pi over 4. So this is solved right away. Whereas for the others, I'm going to use the method we employed before. So sine inverse of 2 root 5 over 5, I'm going to let the inner angle be this, which means sine theta is 2 root 5 over 5, which is y over r. I'm interested in finding secant, which will be r over x. and this is quadrant 1 because sine inverse is positive, which means x is also positive. So x squared plus y squared is r squared. I know this to be 2 root 5. I know this to be 5. I don't know what x is. Okay. Solve this. X squared plus root 5 squared is 5. 2 squared is 4. 4 times 5 is 20. So x squared is 5, x is plus or minus root 5, but I only want the positive value, so I take the positive value. So what is the answer to this question? The answer is secant theta is 5 over root 5. Or in other words, it is root 5 is the answer to this problem. Okay. So I'm going to write down the next problem here, cosecant tan inverse of 1/2. So cosecant tan inverse of 1/2. So I'm going to make the inner angle to be theta, which means tan theta is 1/2. Tan is y over x. Since it is positive, I'm looking at quadrant 1. Okay, so I need to find cosecant theta. Cosecant theta is r over y. So x squared plus y squared is r squared. X is 2, y is 1. Find r. R is square root of 5. R is always positive. So cosecant theta will be r over y. Y is 1. So cosecant theta is root 5 is my answer. All right, I'm solving equation now. 1 minus cosine theta is 1/2, which means 1 minus half is cosine theta, or cosine theta is half. They want the answer in the interval 0 to 2 pi. Okay, so then look at your unit circle. Where is cosine positive? Quadrant 1 and quadrant 4. This angle is pi over 3. This angle is 5 pi over 3. So the answer will be pi over 3, 5 pi over 3. 2 sine theta plus 1 is 0. 2 sine theta is negative 1. Sine theta is negative 1/2. Now, where is sine theta negative 1/2? It's going to be quadrants 3 and 4. So 3, 4. So the angles are going to be 7 pi over 6, 11 pi over 6. 4 secant theta plus 6 is negative 2. 4 secant theta is negative 8. Secant theta is negative 2. That means cosine theta is negative 1/2. Quadrants 2 and 3. Quadrant 2, the angle will be 2 pi over 3, 4 pi over 3. 5 cosecant theta minus 3 is 2. 5 cosecant theta is 5. Cosecant theta is 1. Sine theta is 1, right? Because sine theta is the reciprocal of cosecant. In the interval 0 to 2 pi, this only happens for pi over 2. Then 3 pi over 2 cosine theta plus 2 is negative 1. 3 pi over 2 cosine theta is negative 3. Cosine theta is negative 3 over 3 root 2, which is 1 over root 2 or root 2 over 2. So where is cosine theta negative 2 root 2 over 2? In quadrants 2 and 3, right? So 2 would be 3 pi over 4 and 5 pi over 4. Okay, so you need to have your unit circle memorized if possible, or at least you should have a strategy to find these values. I don't memorize the unit circle. I just remember the first quadrant and then I use the property of symmetry to just figure out the rest of the values. Okay, so then 2 sine squared theta minus 1 is 0. 2 sine squared theta is 1. Sine squared theta is 1/2. Sine theta is plus or minus square root of 1 over 2, which is plus or minus root 2 over 2. So now, which means I want to find where sine theta is either positive root 2 over 2, negative root 2 over 2 positives and 2 negatives. So the answer will be pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. 4 cosecant squared theta minus 3 is 0. Cosine squared theta is 3/4. Cosine theta is root 3 over 2 plus or minus if you take the square root. So that means the answers will be cosine theta, so it's pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Secant 3 theta over 2 is -2. Okay. That means cosine 3 theta over 2 is -1/2. Where is it? Where is this -1/2? Let's see. 3 theta over 2, -1/2. Cosine is negative in quadrants 2 and 3. So -1/2 would be either 2 pi over 3 or 4 pi over 3. Okay. Now, because of the periodic property, you put the plus 2k pi in here. Multiply both sides by 2 because you want, or rather multiply by 2/3 because you want theta by itself. So when you multiply by 2/3, you will get 4 over 9. Am I right? Mm, okay. 4k pi over 3. Okay, so then we are going to give theta values, k values. When k is 0, you will have 4 pi over 9, 8 pi over 9. When k is positive 1, you will end up with 4 nines plus 4/3, right? 4/3 is the same as 12 nines. So this is 16 over 9. That is still within 2 pi. Okay, so 16 pi over 9 works. I can't go anything more than this because that will put me outside my 2 pi, right? So I will not go. Then let me see. 8 pi over 9 plus 4 pi over 3. 4 pi over 3 is 4 times 3 is 12. 3 times 3 is 9. 12 plus 8 is 20. 20 pi over 9. Now 20 pi over 9 is already more than 2 pi, so I cannot use that. So that means these are the three solutions. Okay. So because these are like looking a little bit confusing, I'm going to add one problem here that I would like you to just look at. So for just to make it easy for you to understand where they're going with these problems, okay? Let's take a simple example. Suppose the question asks you, sine 2 theta is 1/2, okay? So then what you're going to do is on the unit circle, you're going to determine that sine is positive in the first and second quadrants, correct? So that means the two angles you're looking for is pi over 6 as well as 5 pi over 6. But because of the periodic property, you know that the period is altered whenever you have some number in front of the theta. So this adding the plus 2k pi needs only be done when you have some number in front of theta. Otherwise, you don't have to. Okay. So then what you do is you have to divide out the 2 in front of the angle. So you divide throughout, okay? So when you divide throughout, this is what you have. Okay, so now you have to find all angles theta between 0 to 2 pi. Okay, so let's do this. Okay, so what we're going to do is we are going to give k some values. Okay, let me make k 0. When I make k 0, this goes 0, this goes 0, right? So that means I'm left with pi over 12 and 5 pi over 12 as my angles. They check out. Then I make my k1. When I make my k1, what happens here? I get pi over 12 plus pi because k became 1. Here you have 5 pi over 12 plus pi. When you simplify this, that is 13 pi over 12 and then this is 17 pi over 12. Okay, now they are both within 2 pi, so both of them check out. Then you go and make k to be equal to 2. When you make it equal to 2, you're going to have pi over 12 plus 2 pi. Now that is already going to put you over 2 pi, isn't it? So you don't have to even bother going there. So what are your solutions then? Your solutions will be pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Okay, so that's how you come up with the answer. Now, suppose say you had this sine of half theta is 1/2. Start the same way, 1/2, quadrants 1 and 2, right? So pi over 6 plus 2k pi, and then you have 5 pi over 6 plus 2k pi. Then multiply this times by 2 because you want to get rid of the half. So then you will have pi over 3 plus 4k pi. Then you will have 5 pi over 3 plus 4k pi. Now these are much better because you don't even have to make your k into, so let's see what we have to do here. Let me not jump. So now first I'm going to make k 0, right? Then your angles are pi over 3, 5 pi over 3. Easy. Now I can't make k1 this time because if I make it 1, this will become plus 4 pi, right? 4 pi is out of the limit. I don't have to bother with it. Okay? So that is gone. So that means that's it, right? I have only two solutions here. You see? So it makes my life easier, doesn't it? So my answer is just pi over 3 and 5 pi over 3. So because what happens when you have a half in front of the theta, it just means that the period, right? Remember the period is 2 pi over omega, right? So 2 pi over half is 4 pi. So that means it takes 4 pi to complete one period. So this is 2 pi, correct? So now when you want to find out where this value is 1/2, you see it is only 1/2 at these 2 points, right? And this value is pi over 3 and this value is 5 pi over 3. So that's what it means, okay? So doing this graphically is another way that you can solve. You know, sometimes if you feel like that's easier for you, you can do that, but this is the method, okay?